How are the seats in your classrooms arranged? Are they lined up neatly in rows, or are they grouped in clusters? A configuration is an arrangement of objects in a given space. Some configurations are more stable than others, meaning that they are less likely to change. The position of the gymnast on the balance beam in the given figure is not very stable because the beam is only 10 centimeters wide. A gymnast on a balance beam is like an atom in an excited state, not very stable. An electron configuration is the arrangement of electrons in the orbitals of an atom. The most stable electron configuration is the one in which the electrons are in orbitals with the lowest possible energies. When all the electrons in an atom have the lowest possible energies, the atom is said to be in its ground state. Alright, so to write the electron configuration of lithium, I'm going to start with 1s2. I'm going to copy it. So that is 1s2. That means the first two electrons is in the first energy level. And then I'm going to move to the second energy level and I'm going to copy 2s. But if you will notice, I just write 1 instead of 2 because if I'm going to add this 2 plus 1, the total is 3, which is the atomic number of lithium. If a lithium atom absorbs enough energy, one of its electrons can move to an orbital with a higher energy. So this configuration is referred to as unexcited state. Unexcited state is less stable than the ground state. Eventually, the electron that was promoted to a higher energy level loses energy and the atom returns to the ground state. Helium, neon, argon, krypton, and xenon, atoms returning from excited states to the ground state, emit the light you see in neon lights. Alright, this time let us have the electron configuration of the following elements: hydrogen, helium, beryllium, boron, carbon, and nitrogen. Alright, for helium, we have an atomic number of 2. And then for beryllium, we have an atomic number of 4. For boron, we have an atomic number of 5. And then for carbon, we have an atomic number of 6. And then for nitrogen, we have an atomic number of 7. Okay, so this time let us have the configuration or the electron configuration of the following elements. So I'm going to start with hydrogen. So I'm gonna write here 1s1. Why? Because the atomic number of hydrogen is only 1, so that means the electron is in the first energy level. So if we're going to follow the electron configuration mnemonics, for helium, that will be 1s2. And then for beryllium, that will be 1s2. And then I'm going to jump to the next energy level. That will be 2s2. And 2 plus 2 is 4. Alright? So that's the atomic number of beryllium. And then for boron, I'm going to start with 1s2. Then I'm going to jump to the next energy level. That will be 2s2. Followed by 2p1. So the electron configuration of boron is 1s2, 2s2, 2p1. So if you're going to add it, 2 plus 2 is 4 plus 1 is 5, which is the atomic number of boron. Alright, so this time we're going to have the electron configuration of carbon. We're going to start with 1s2 and then 2s2, and then I'm gonna write 2p2. I'm not gonna write 2p6 because the atomic number of carbon is 6, so I'll just write 2 because 2 plus 2 plus 2 is equals to 6, which is the atomic number of carbon. Alright, so this time let us have nitrogen. I'm gonna start with 1s2 and then 2s2, and then I'm gonna jump to 2p3. I'm gonna write 3 because 3 plus 2 is 5 plus 2 is 7, which is the atomic number of nitrogen. So this is how you're going to write the electron configuration of these elements. Hydrogen is 1s1, helium is 1s2, beryllium is 1s2, 2s2, boron is 1s2, 2s2, 2p1, carbon is 1s2, 2s2, 2p2, and then nitrogen is 1s2, 2s2, 2p3.